Our first method for solving a quadratic equation algebraically is solving by factoring. Solving by factoring requires setting up your quadratic in the form ax squared plus bx plus c equals 0 first, and then rewriting it in a factored form. The idea is once you have it in a factored form and it's equal to 0, you know that when the product is equal to 0, one of the factors must also be 0. For example, if a times b is equal to 0, the only way for that to be true is either a is equal to 0 or b is equal to 0, and at least one of those must be true. Let's take a look at an example. So our very first example is not actually in the form we would like it to be in. We want to move the 15 to the other side of the equation. So the first thing we do is we rearrange so that one side of the equation is equal to 0. So x squared plus 2x minus 15 equals 0. Now we can factor. To factor, we look for a pair of numbers that multiply to negative 15, but add to positive 2. All right, let's use those numbers. We have x plus 5 times x minus 3 is equal to 0. At this point, one of two things must be true. Either our first factor or bracket must be equal to 0, x plus 5 equals 0. If that's not true, our other case is that x minus 3 is equal to 0. And each of these cases gives us a possible value for x that will make the original equation true. Our first case, if we solve for x is equal to negative 5. In our second case, if we solve for x is equal to 3. If we're not sure and we want to check this, take each x value and put it back in the original equation. I'll show you how to set up the test for one on the side here. So instead of x squared, we could calculate negative 5 squared plus 2 times negative 5 is equal to 15, and we verify if the equation is true. This is going to be 25 minus 10 equals 15, and we see that works, so we have verified that x equals negative 5 is a solution. And then you can do something similar with the other x value if you need to check that as well. Let's take a look at a second example. So our second example has already got one side of the equation equal to 0. That part is fine. The next thing we want to do is we want to factor the non-zero side. In this case, if you can notice the pattern, you may notice that you start with a perfect square, you end with a perfect square, and your middle term works out perfectly so that it is the square root of the first term times the square root of the last term, times 2. In this case, we factor it really easily as a perfect square of 3x minus 2 squared equals 0. If you don't recognize it, you can also factor it the long way. Now, in order for this to be true, we also know that the square root must be true. There's only one unique factor, so it must be equal to 0 in order for the original equation to be equal to 0. And we now solve for x. This one can be done in 2 steps if you need to. 3x equals 2, and then x equals 2 over 3, keeping an exact answer or a fraction. This is where I usually write a little reminder. Exact values. That could be a fraction. That could be a radical. It is not a decimal. Notice the pattern we're using here. So for example, if you have a solution or a root of 3, the factor that we got that from was x minus 3. We can generalize this using a variable. So for example, the root b will come from a factor x minus b. If you end up with a fractional root, it came from something originally like ax minus b. There are 3 examples below that you can try as an exercise. This is where I recommend you pause the video and try them, and then come back and I'll work through them as well. All right, let's work through these in a little bit of empty space, starting with a. For a, we have x squared equals 5x We rearrange to put everything on one side of the equation. So x squared minus 5x equals 0. To factor this, we only have two terms, so let's look for a greatest common factor like x, leaving us inside the bracket with x minus 5, and that is still equal to 0. This gives us two potential solutions. Our first factor x could be equal to 0. That would make the equation true. Or our second factor, x minus 5, could be equal to 0, in which case x is equal to 5. If we want to combine our solutions, we can write x is equal to 0, comma 5. Let's try the second one. This one is 2x squared equals 6 minus x. I do want to put everything on the same side of the equation. I would also like to have a positive x squared term, so I'm going to put everything on the left side of the equation. So 2x squared plus x minus 6 equals 0. In order to factor this one, you can use the method of your choice. I'm going to use the box method. So I'm going to find two numbers that multiply to negative 12, but add to positive 1, and I'm just going to set up a box for factoring purposes. We have a 2x squared and a minus 6. We're looking for a pair of numbers that multiply to negative 12, but add to positive 1, so that would be 4 and negative 3. So the other parts of the box will be 4x and negative 3x. I'm going to temporarily highlight. I will factor the first row like that and look for the greatest common factor. In this case, that's going to be 2x. And for the next one, it will be minus 3. Same thing for the first column. Really, all they have in common is an x. And then the next term has a plus 2 in common. So our factored form will be 2x minus 3 times x plus 2 equals 0. Once we've got it factored, it's now pretty easy to find our solutions. We have two cases. Either 2x minus 3 will be equal to 0, in which case x is equal to 3 over 2, or x plus 2 equals 0, in which case x is equal to negative 2. And if we'd like to write those together, x is equal to negative 2, comma 3 over 2. All right, let's make a little bit of space and try C as well. C has some fractions. I'm sure we're all very excited for those. C is x squared plus 8 over 3x minus 1 equals 0. Now you can factor this with fractions. You can also make it a little bit easier and not have the fraction. So I notice I have a 3 in the denominator. What I can do is I can multiply the entire equation by 3 as long as I do it on both sides of the equation. And that won't actually affect the right side because 0 times 3 is still 0. But that gives me 3x squared plus 8x minus 3 equals 0, which may be a little bit easier to factor as it doesn't have a fraction. We can use the box method again. Two numbers that multiply to negative 9, but add to positive 8. So that sounds like positive 9 and negative 1. Setting up our box. We have 3x squared minus 3, and then we have plus 9x and minus 1x. Factoring the first row, greatest common factor of 3x, and if there's nothing else, it's just a factor of negative 1. Coming at the top, we have a greatest common factor of x, and then a greatest common factor of 3. This first term with the higher degree is positive, that's why I'm only factoring out a positive 3. In factored form, this gives us 3x minus 1 times x plus 3 equals 0. and two possible solutions. Either 3x minus 1 is equal to 0, in which case x is equal to positive 1 over 3, or x plus 3 is equal to 0, in which case x is equal to negative 3. So our two final solutions, I'll write them together, are negative 3 and 1/3. This would be a good point to practice some of the basic solve by factoring questions before we go on to a more difficult example.